Hi everyone, I'm Stephen Shavin Meshak and my student ID is 34114707. Today I will be presenting my cinema seating allocation system developed for the Advanced Topics in Software Engineering module. This project is designed to automatically allocate the best possible cinema seats for customers while following real-world business rules such as group seating, seat preferences, accessibility requirements, and prevention of inefficient seat gaps. The system was developed using Python Flask for the backend, HTML, JavaScript, and Bootstrap for the frontend, and JSON files were used for data storage. To start with, let me log in as a user. So once I log in, I need to select a movie and then a showtime. So this screen shows the layout of my cinema seat booking system that I have developed. To start with, let me explain the algorithm logics that I have implemented in the system. The core of this project is a score-based optimization algorithm implemented inside the allocation algorithm class. The purpose of the algorithm is to find the best available seat arrangement for customers based on their group size and preferences. Instead of randomly selecting seats, the algorithm evaluates every possible seat combination, calculates the score for each candidate allocation, and returns the highest scoring result. The scoring logics I have implemented to start with is adjacency bonus. For every pair of adjacent seats, the algorithm adds positive points to the score. This encourages the system to keep group members sitting together in the same row. The adjacency bonus value is plus 15 per adjacent pair. The next logic I have implemented is the gap penalty. If selected seats contains empty spaces between them in the same row, the algorithm subtracts points. This prevents inefficient seating layouts with unnecessary gaps. The gap penalty is minus 5 per gap seat. The next logic I have implemented is the isolation penalty. The algorithm checks whether placing a booking would leave a single empty seat trapped between occupied seats or between a seat and the edge of the row. These isolated seats are difficult to sell later, so the system strongly avoids creating them. A minus 20 penalty is applied for each isolated open seat. The next scoring logic I have implemented is the position scoring. Seats allocated in center rows, especially rows E to I, receive the highest scores because they provide the best cinema viewing experience. Seats near the center columns also receive additional bonus points. Front rows receives a small penalty because they provide less comfortable viewing angles. The next logic is the preference matching. The system also considers customers' preferences. If the selected seats exactly match the customer's requested section, row range, or price preference, additional points are awarded. Exact matches receive higher scores than partial matches. The next logic is group split penalty. If a group must be divided across two rows, the algorithm applies a group split penalty. This ensures that single row seating is always preferred wherever possible. All these scoring factors are combined together inside the allocation scoring function. The algorithm calculates a final score for every candidate seat arrangement. All candidates are then sorted from highest score to lowest score, and the highest scoring allocation is returned to the customer. Also, I implemented the three-tier search strategy. Tier 1 includes single row adjacent seating. It scans each row using a sliding window approach to find consecutive available seats. This is considered the ideal result because the entire group can sit together. The next tier is the cross-row seating. If the algorithm cannot fit the entire group into one row, it moves to the second tier. Here, the group may be split across two nearby rows such as row D and row E. A group split penalty is applied so that single row seating is always prioritized over split seating. Tier 3 is fallback based insertion. If neither adjacent seating nor cross-row seating is possible, the algorithm uses a fallback strategy. It individually ranks all remaining available seats based on seat quality and selects the top ranked seats required for the group. This tier receives an additional penalty because it is considered the least desirable arrangement. Next, I'll give an overview of the functions, how it works. To start with, on the left, I have the group size. So I can select the group from 1 to 7. So if I click 7, and then in the section, I can filter it using any regular VIP or disability. So To start with, let me book some disability seats. So as in the requirements, the disability seats are between the first and the second rows and they are adjacent. So currently I have six disability seats. So if I try to book seven, if I try to book seven disability seats, I get an error message saying only six disability seats available, but seven requested. So if I try again to reduce the count and then find it again, then I am able to book these seven seats. So currently it's the total is 72. If I added the senior member discount, a 20% discount is added and the bill is reduced to $57.60. I can click reserve seats and then confirm bookings. So right now all the disabled seats are booked. If I try again to book again a disabled seat, let's say the group size is 1 and I try to find best, I get an error message saying only 0 disabled seats available. So likewise, let me go to book another different section. So if I book a seat for any and then find best, it will prefer the center and VIP section row because it is the ideal place to for cinema experience. So I can book it and I can book it with the senior discount or the senior discount unchecked. So right now I click reserve, and once it reserved, this color it's showed as reserved. So if I don't want to confirm the booking, I can just cancel the booking by click clear. The next function is booking VIP seats. So let's say I need to book four VIP seats. So here it gives a priority to a single row VIP seat. So if in case the seat count exceeds to 7, it will be break down into two rows likewise. So I'll book this one as well. And apart from that, I can book regular seats in a number of count. If I book again, it will anyway prioritize the rows E to I and book in a single row group since these are available. I'll book one more. Yes. And the single person. So the single person, if I try to book it for a regular section, this is how it prioritizes. It won't group it near the groups. It will group in a separate section, but still prioritizing between the E and I groups, and I'm able to reserve it. The sections in seat number 21, 22, these orange color ones are the broken seats. So when I try to click it, I get a message saying this seat is broken. So these are the high level functions for a user. So apart from these functions, the user can go and check his bookings. Yeah. So let me log out from the user and log in as an admin. Enter the admin username and admin password. For so this is the admin dashboard. The admin is able to add new movies, edit those, delete, and as well as he's able to schedule show times, view the bookings, and seat management. So let me show the admin override function. So if I go here and then if I open show time, so let's say the same one Dune part 2, and if I click book as an admin, you can see the broken seats available. So if I click this admin override button and then click this seat number H21, and then I'm able to reserve it and then confirm the booking. So right now the seat number H21 is booked. Apart from this, the admin is also able to manage the seats. So uh, he can like manually set the seats to mark it as broken or mark it as repaired or reset or check gaps. So apart from the logic that I have implemented to randomly implement the broken number of seats, I can also manually check it and manually change it. To conclude, the project demonstrates how optimization algorithms and software engineering principles can be applied to solve real-world cinema seating problems. The system combines intelligent seat allocation, weighted scoring logic, business rule enforcement, concurrency handling, automated testing, and a fully functional web-based prototype. Thank you for watching my presentation.